Chapter 9 is about significance tests. A significance test is a formal procedure for comparing observed data with a claim. So the first part of this chapter is we need to be able to state what our claim is, and that is called stating the hypothesis. Stating it's actually two hypotheses. Stating hypotheses. So first what we do is we state what's called the null hypothesis. Null hypothesis. And this is sometimes known as the statement of equality or of no change. It's almost always going to be equal to. So null hypothesis, the symbol for that we'll use from now on is H0, null hypothesis. And this is basically the claim you want to find evidence against. Claim you want to find evidence against. Because if you can find evidence against it, so null hypothesis, it's almost a statement of equality, you'll see in the examples. If you can find evidence against it, then you can say that we can conclude the alternative hypothesis is valid. Alternative hypothesis. And that is H sub A, ha, ho and ha. Alternative hypothesis. And this is actually the claim you're trying to find evidence for. Claim trying to find evidence for. So if you reject the null hypothesis, then you can say that your alternative hypothesis is true, and that's what you want. There's two types of alternative hypotheses. They are one-sided or two-sided. One-sided or two-sided. And so that word means one-sided is if the parameter, which remember is what we're trying to determine about the population, if the parameter like the mean or standard deviation is either greater than or less than the null hypotheses. Two-sided is if the parameter is different or not equal to. Parameter is different, not equal to the whole null hypotheses. So this is either greater than or less than. That's why it's called one-sided. Two-sided, the parameter is not equal to. Okay, more terminology, and then you'll see how this all fits together in an example. Let's say we have, so we need to define what the p-value is here. P-value. So the p-value, what is that? The p-value is the probability if H0 were true, the null hypotheses were true, the probability if the null hypothesis were true that we would get the observed result. That the observed result, the statistic that we gather from the sample, that the observed result statistic would happen. What's the likelihood it would happen if H0 were true? Okay, so what we want ideally is we want small p-values, and we'll talk about later how to calculate that. So don't worry about that. Small p-values, we want that, because that means we can reject h0. If there's a very small likelihood that it would ever happen, then we can reject h0 and therefore conclude what we're trying to prove, which is the alternative hypothesis. Reject h0 and conclude the alternative hypotheses. For large p-values, we fail to reject h0. Fail to reject h0. So we can't conclude anything. Cannot conclude the alternative hypotheses. Cannot conclude h sub a. Okay? Again, you really have to see how all this fits in an example, and we will get there. So then the question is, how small a p-value is needed? Because we said if the p-value is small, we could reject h0. So how small? Well, that's when we get into the significance level. So how small a p-value needed? Question. How small a p-value needed? So that's known as alpha, which is the significance level of the test. Significance level. So what does that mean? For example, if alpha were 0.05, we would require data. We require data to give evidence against h0 so strong it would only happen less than 5% of the time by chance alone. What we get with our statistic would only happen less than 5% of the time. And so if the p-value is less than alpha when we do a test, if our p-value is less than alpha, then our data are statistically significant. Our data are, if the p-value is less than alpha, the data are what's called statistically significant. At the level alpha. At the level alpha. So we reject. So reject the null hypothesis. Reject h0. Okay. And let's look at this in the next video. We'll look at this in some examples.